So we're going to start by recapping some of the ideas that you covered in the last lesson. To begin with, we looked at factorising quadratic expressions. So remember, a quadratic expression is an expression that contains an x squared or a squared term as its highest power of the variable. So for instance, an example could be x squared plus 12x plus 20. Now, splitting this up into its factors, we know that we can write these as a pair of brackets, which will, in this case, both begin with x. And we looked last lesson at the pattern, which tells us that the two numbers inside the brackets will multiply together to give us 20, and they will add together to give us this value 12 here. So that is going to give us a combination of x plus 10 and x plus 2 multiplied together. There is only ever one correct answer. So for instance, we know that 5 multiplied by 4 also gives us 20, but 5 plus 4 does not equal 12. So we can't use the combination of 5 and 4. It has to be the 10 and 2 combination. Now, how can you check that you've done this correctly? You can check by expanding your brackets. So you will get x squared plus 2x plus 10x plus 20. So of course this simplifies to x squared plus 12x plus 20. So we've done this correctly. Now if you wanted to, you can write the brackets in the other order, x plus 2, x plus 10, but the numbers used in each example and the signs of the number must not change. Let's do one further example. We will have x squared plus 2x minus 48. So I need to think of a pair of numbers that multiply together to give me negative 48, but add together to give me positive 2. Well, what pair of numbers could I have? Let's think about factors of 48. Well, we've got 24 and 2, although one of them would have to be positive, one of them would have to be negative. We've got 6 and 8, and as soon as I think of 6 and 8, I know there's a gap of 2 between them, so that's going to be the correct combination. I need the numbers to add together to give me positive 2, so that tells me it's got to be positive 8 and negative 6. That's the only correct combination that will work. And again, if you wanted to, in theory, you could write the brackets out as x minus 6, x plus 8, but notice in every case, it's a negative 6 and a positive 8 as the combination that we use. I'm going to write down 4 more questions, and in each case I would like you to factorise each of these expressions. So here are the 4 questions. Pause the video, factorise each example, and then check whether you've got the answers correct. So let's see if you were able to answer these correctly. So question 3. We should find we have x plus 3 and x plus 8 as our pair of factors. Question 4, x plus 7, x minus 5. Question 5, we have x minus 6, x add 2. And question 6, x minus 5, x minus 6. Brackets can be written either way around, but the numbers must be the same and have the same sign. Now, most of the examples of quadratic expressions that we've seen so far have involved 3 terms, but a quadratic can be any expression where the highest power is a square. So we're going to have a look at some very simple 2-term quadratics to start with. So let's take a look at x squared plus 3x. It's a quadratic because the highest power of the variable x is a square. Now, quite often what we find is once we've studied quadratics for a while, people start to look at expressions like this and then struggle to factorise them, even though this is actually an incredibly easy expression and you all would have been able to factorise this with barely a thought before you'd ever even heard of quadratics and quadratic factorisation. How would you factorise an expression like this? Well, it's super easy because both terms have a common factor of x, which means that you can write x and then within a bracket, in this example, it would be x add 3. So we don't need a double bracket here for this factorisation. Let's take a look at another example. 2x squared minus 6x. It's quadratic, and there's a coefficient of 2 in front of the x squared term, but as with the previous example, both terms have a common factor of x. And this common factor of x can be taken out of a bracket like this, leaving you with 2x minus 6. But is that a true factorisation? It's a partial factorisation, isn't it? Because, of course, there is a common factor of 2 as well. So really, if we were going to factorise this properly, we would need to take both 2 and x outside a bracket, and then inside the bracket it's simply going to be x minus 3. So if you have two-term quadratics where both terms have a common factor of, for example, x, you only need one bracket for the factorisation. I have sometimes seen people try to factorise expressions like this in this way, where they try and have a double bracket and then have one bracket as x plus 0 or x minus 0, but that's really pointless because x add 0 is just the same as x. So it makes absolutely no sense really to write x plus 0, x plus 3. It's just a waste of time, so please make sure you don't do that. So a number of examples are going to come up where you've got two-term quadratics with a common factor in each. Factorise each of these using one bracket only. So here are your questions. Factorise each of these two-term quadratics, please. So let's quickly check your answers. Question 3, we should have x bracket x subtract 4. Question 4, y bracket y plus 3. Question 5, p bracket p plus 5. And question 6, 3x is one factor, and then the bracket containing the other factor is x minus 4. So remember, when you are factorising a two-term quadratic, where both terms have a common factor, you only need one bracket in the factorisation. So we're now going to have a look at another type of two-term quadratic. Let's have a look at an example. So here it is, x squared take away 4. Now, it's definitely a quadratic because the highest power of x involved is x squared. It contains two terms, but unlike the examples we saw previously, these two terms have not got a common factor. So how do we factorise this? Well, one way we can do this is by thinking about this very carefully. So we have an x squared term, we have a minus 4 term, and we have an x term, but the coefficient or the multiplier of this is 0. So I could, in theory, write this as x squared plus 0x minus 4, which isn't a very nice mathematical way of writing something, but for the purposes of thinking about it, it is quite useful. Because now we know that when we factorise this, and we find the pair of factors, the brackets will both begin with x, and the numbers that we're looking for will need to multiply together to give us negative 4, but add together to give us 0. Now there's only one pair of numbers that will do that. 2 multiplied by negative 2 will give us negative 4, and 2 add negative 2 will give us 0. So the brackets are x plus 2 and x minus 2. And you can do a little check by expanding. So we get x squared minus 2x plus 2x minus 4, which simplifies to x squared minus 4. And that's crucial here, because both brackets are essentially the same, but one is plus 2, one is minus 2. When you do the expansion, you get this neat middle section here where the x terms cancel. So let's have a look at another example. Let's call this example 1, example 2. X squared minus 9. So again, you may wish to rewrite this as x squared, and then in the centre, plus 0x, or you could have minus 0x if you wanted, it doesn't make any difference. You still got 0x's, and then minus 9 at the end. So what are our brackets going to look like? Well, they have to start with x, and we then need to find two numbers that multiply together to create 9, but add together to create 0. So again, what's the only combination that will do that? 3 and negative 3. So my brackets are x minus 3 and x plus 3, or written the other way around, x plus 3 and x minus 3. And again, you can expand to check that if you need to. Now, these sorts of expressions, x squared minus 4 and x squared minus 9, are called the difference of two squares, hence the title here. Now, why are they called that? Well, because x squared minus 4 is a difference of two squares. Difference means subtract, and it's the difference between x squared and 2 squared. X squared minus 9 is the difference between x squared and 3 squared. So could you factorise the third example? X squared minus 25. Try and do it straight away. What do you think it's going to be? We need an x and an x, and we know that we need the numbers inside the brackets to multiply together to give us negative 25, and we need that cancellation, so yes, it's plus 5 and minus 5. Now, what we're going to see is whether we can generalise what we've just looked at. So let's take a look at a general difference of two squares. So I've got x squared minus, and instead of a specific number, I'm going to say y squared. Now, y squared could be 2 squared, so 4, or y squared could be 5 squared, so 25 there. But I'm going to do this algebraically. Can you work out what would go in the brackets for the factorisation here? You know they've got to start with x and x, and you know they've got to end with y and y, so that you multiply back or expand to get y squared. And you should know from the previous examples that you're going to have x plus y and then x minus y. Now, you can do a quick check to see that you've done this correctly. So we get x squared minus xy plus xy minus y squared. Now again, what happens? Your minus xy and your plus xy cancel, leaving you with x squared minus y squared. So this is a really useful strategy that will help you factorise the difference of two squares. So we're going to have a look at a few more examples. If you prefer, as soon as each example pops up on the screen, you can pause the video, have a go at yourself, and then watch the completion of the answer. Or if you feel you need a little bit more support with this, you can just watch the video the whole way through. So here are the examples. Number 1, a squared minus b squared. So very similar to above, a plus b, a minus b. What about this one? X squared minus 1. Now, people often forget that 1 is a square number. It's the square of 1. So the factorisation would be x plus 1 and x minus 1. Right, number 3. A little bit different. X squared minus 4y squared. Now, can you see the two squares here? Because, of course, 4y squared is the square of 2y. So my factorisation would be x plus 2y, x minus 2y. And building on from that example, number 4, 9x squared minus 25y squared. Still a difference of two squares, because 9x squared is the square of 3x, and 25y squared is the square of 5y. So we have 3x plus 5y, 3x minus 5y. Number 5, 100 minus x squared. Now, I suspect everyone would have been quite happy to factorise x squared minus 100. All I've done is reverse the order of the terms, so the brackets can begin with 10 and end with x, and we have plus and minus. Now, one last example, 2x squared minus 18. Now, a lot of people will look at this and say, well, it's not a difference of two squares, because 2x squared is not a true square and 18 is not a square. Wrong. It's a difference of two squares in disguise. Now, what I often see in examples like this is people spot that there is a common factor of 2, and they write this as a product of 2 and then x squared minus 9, and then they stop. And that's a bit of a fatal error here, because the difference of two squares is here. So what we can do is then write this as 2, and then we write our difference of two squares as a product of factors x plus 3, x minus 3. So the final answer to the question, which is the factorisation of 2x squared minus 18, is this product of three factors over here.